We're now going to assemble our elbow engine. We're going to open a new tab and start a standard millimeter.iam. Now, one of the things that's very important with World Skills competitions is you will be marked on putting all of the parts into the assembly in the correct logical order. So we will open your assembly when we're marking to make sure that you have put them in the correct order. In this example, you've been given an assembly drawing which has a parts list in the top left hand corner, and this shows you the correct sequence of how to place the parts in. So for the elbow engine, we're literally going to follow the parts list. So number one is the base. Now I just want to show you something before we get started. If you go into your application options and go to your assembly tab, there's a tick box which says place and ground first component at origin. And what that does is every part that you put in first, so placing your first component, it will actually put all of the planes or all of the axes together, so the X, Y, Z, it will line them all up for you. And the reason we want to do that is we want our base part to be fixed so that everything's not floating around in space. If you look at it, that it saves you adding the 3 constraints of all the planes together. So that's a good thing to have on in your application options. So if you want to do that, you can just tick it on and off, and then you can apply that. If you hit P for place, or of course go up into your browser up here, you'll then be met with the Windows Explorer button, and as we know from looking at the parts list on the drawing, we know base is the first component that we're going to put in. So I'm going to double click on that or press open. And you can see that it's put the base in and it has locked that one, and what it will allow you to do is place more instances of the component. Obviously, for example, with the M5 shoulder screw, which is item number 4, there's 2 of them, so you could place 2 down. For this we only need 1, so I'm going to press escape, and then we're left with this 1 item. In the browser you can see there's a little drawing pin. That means that it's grounded. So if you remember, we grounded this when we changed the application options. So now if I hover over it, you can see again a drawing pin with, in England, that's the Earth symbol, but in America that's called ground. So that should be a good way of reminding you what it is. It's grounded. And you can right click on a component and it's a tick box, so you can untick it there. You can also do it in the browser, just so you're aware, but I would recommend you always leave your first part grounded. And if I try and drag and move this around, it won't let me. So we now have our base part in. Second part that is listed in the parts list on the assembly drawing is the valve port block, so I'm going to go and put that one in next. And again, I'm going to place 1 instance of it, that's all we need. And then press escape. We're now going to start assembling all of this together. I'm going to try and show you as many constraints as possible. Might not be the best way of doing it, but it will allow you to see all the different ways that we can do this. So I'm going to go ahead and do that now. So if you remember modelling this part, I've just clicked G, which allows me to rotate this component just on its own, just so you're aware. If you remember, we put in these 2 holes on the underneath of the valve port block. Funnily enough, they add up with these 2 holes just here. So what we're going to do is you could use what's called the insert constraint, but I'm going to use that one later. So I'm just going to show you a different way of doing it, just to show you a different constraint. If you press C or constrain in your relationships panel, you then get in your constraint box over here, okay? So now we've got types of constraint along here, and each type has a solution. So the first thing I'm going to use is a mate type and a mate solution. And what that allows you to do, you can see by the graphic there, you can pick 2 faces and it will put them together. And it will also make that noise, which is, if you're an inventor geek like I am, that will be a very satisfying noise. So I'm going to hit apply for that one. And then what we can now do is use, if I just rotate this around just so you can see, I'm now going to align these holes here with the holes that we've drilled in the base. So if I go into mate again, and what I'm going to do is if you hover over an edge, you'll see that green dot, and that'll be the midpoint of that circle, whereas if you hover over a circumferential face, you get the whole axis. So that's what we want to do. We want to align this axis with the axis of one of our holes in our valve port block, okay? So now if I apply that one, I'll just rotate it back round. You can see what we've done there. So you can now see it's fixed in that axis, and the 2 faces are also fixed together. So the last thing we now need to do is align this hole just here. So we're going to use mate type, mate solution again. I'm going to pick up on that axis, and then I'm going to use the axis of the valve port block as well. And now you can see, if I just escape out of that, you can see if I try and move this around now, I can't, because this is now fully constrained. If you need to delete or edit your constraints, you go into your browser and you can see them there. There's the mate of the axes, and there's the mate of the other axes. Now I need to place the next part, which is item number 3, which is the cylinder vert. So if we place that one in, and I'm going to press escape because I only need one instance of this. We've now got this part here, which aligns on here. So I'm going to open the constraint box again. Now we could, of course, make this face here to this face here. We're not going to do that. I'm going to use what's called an insert constraint. And what an insert constraint essentially does is it does two things at once. It will do the axis, and it will also do this edge here. So you're effectively doing the face-to-face mate we did earlier and the axes mate. So if I click on this edge axis here and then the edge axis here, and I could choose the inner one there, but I'm just going to choose the outer one here. You can see what it does. It actually puts the two of them together. Now if you hit apply, we've constrained that part, so you can see it's a lot quicker. Now what we're going to do is we're going to make this assembly as if it were in real life. So this part here is completely fixed, whereas you'll notice that this is one of the cylinders, so this will be rotating, so we're going to leave that free to rotate for now. Okay. Next we need to add item number 4, which is the M5 shoulder screw. So if you go place and then open your M5 shoulder screw, we actually need 2 instances of this, so I'm going to put 2 down. You can right click OK or press escape, and you can see that one of these is actually to hold this cylinder vert in, so I'm going to hit constrain. And again, I'm going to use insert. I'm going to select this one here and that edge there, and you see that's now put in there. And hit apply. Another one I was going to show you, just to use it. Of course, in real life, this bolt wouldn't be free to move when it's in the done up position. So what we're going to actually do is just add another constraint, which is this one here, angle. In the angle, you've got 3 types of solution. The one we want is just a simple directed angle, so you need 2 faces, and it will make them at 0 degrees or an angle that you dictate. So I'm going to select the face there and then just any of the other square edges. You can see it's 0 degrees. Now if I hit apply, you'll see that this is now locked in position. We're going to move on to item number 5, which is the flywheel post. So again, P for place, flywheel post. I'm going to put this one in. Hit escape. I'm going to use the constraints again. I'm going to use insert, and I'm going to line these up with the holes here and apply that. And then the second constraint I'm going to use, just use a different one. I'm going to use the mate, and I'm going to select this axis and then the axis under here. So just zoom in a little bit, and you can see that's added those. Just to make sure, yeah, that is the right way around, because we need to make sure it is, because of course this is handed. So we've got, I'll just spin this around just to show you. We have got this here, which is where the next part will be getting added on. So we've now got to add in part number 6, which is the flywheel web. So if I place flywheel web, add that in. And then part number 7 is the flywheel rim, and you'll be able to see that what happens here is the web sits inside the rim. So I'm going to use again the insert, and there's the little shoulder edge in here. Okay, so I'll just zoom in just so you can see where I am clicking. So right in here, you can see we've got this shouldered edge here. So it doesn't matter which of those diamonds you click, as long as you are making sure that the web is sat in the correct position. It's not overlapping, which it isn't, so I'm going to hit apply. Now one of the other things we've got to do, which is also why it's very important that you always model correctly around a center point, is at the moment these two are independent of each other along the axes. They can spin. So what we're actually going to do is expand in here our browser, open up our origins, and you can see we've got all the YZ plane, XZ plane, XY plane. I'm actually going to use that angular constraint again, or you could use the mate. So let's use the mate, and we'll use the YZ to YZ, and that's put those 2 planes together. Now if I hit apply, these 2 are now sort of locked together, which is what we want. So we've now got almost like a little sub-assembly here with our flywheel. The next thing we need to add is our cylinder horizontal. So P for place, cylinder horizontal, and put that one in there. We only need one of those, so just hit escape. And we can now start to add these 2 together, and then we can put this onto the main assembly. So again, I'm going to model it, assemble it as if I would in real life. So if you check on your assembly drawing, there's a section view which shows how these parts are going together. So it basically all holds itself in. So if I do a constraint, use the insert and pick this edge and then this edge here and apply that, and then when we put the bolt on to this side here, that holds the cylinder onto the web and then the web onto the rim. Okay, so we're now going to attach that sub-assembly. Actually, before we do that, the other thing we need to do is this is now, can you see the cylinder is still horizontal, is still able to go around along that axis, so we're going to lock that also to the web. So I'm going to shut the rim down and expand this one, and we got the YZ in there. Again, constrain that to the YZ, so you can now see they're all locked together as well. And I'm just going to use the insert constraint to get this cylinder constrained into our post. Apply. So now, hopefully what that's showing you is now that whole assembly is turned. If I go around to the other side, just make that, you can see that the whole assembly is now rotating around. So the other thing we need to do is just put the M5 shoulder screw to keep it all locked in together. And like we did earlier, I'm just going to put an directed angle constraint on that face, and let's say that bit there, just 0 degrees. So now you can see we got that, it's rotating around there. We're almost there, so we've just got a couple more parts to do. We now need to add in the piston. There's 3 instances of the piston. So what we're going to do is, before I do that, I'm just going to go around to this other view using the view cube, and what I'm going to do is I'm going to right click on that little house there, and I'm going to set the current view as home. So if you press F6, and I'm going to change the fit to view, so now wherever we end up, if I press F6, it will bring it back to this view here. So I'm going to place component, piston, and we need 3 of these, so there we have it. And now what we're going to do is we're going to use the axis of these pistons, and we're going to start assembling it. So hit apply, and again this axis here. So you can now see, if I start to rotate this around, you can see how this engine works. Okay, so the elbow pistons go in and out and rotate it around. Okay, so the next one, in here. Zoom in. So I'm doing the same constraint as last time, and now you can see this one going around as well. So what I'm now going to do is do the last one, and just be very careful when you're doing this, because I have seen it in other competitions where these pistons actually overlap, where somebody's constrained them in the wrong order. So when I finish doing this one, I'll just show you what I mean. So you can now see if this is turning around, none of them hit into each other, they're not intersecting, they're not overlapping. Okay, so that's now all going around, and you can see how it works. Perfect. So press F6. And the last thing is there are 4 screws which are given to you as an IGES file. So we're going to insert those, okay, just to show you can use generic file types, so like IGES or IGS for an IGES file. You can use stepfiles.stp. You can also import from other CAD packages as well. So it's same as normal. You press place, and in here it's only looking for IPTs and IAMs, so inventor parts and inventor assemblies. If you go down here, you can change it to all files, and you can see all the different types of files in here that you can import. We know this one's an IGES file, so you could change it to this one. I'm just going to show all files just so you can see. And in there we've got the M5x8 socket head cap screw. So if you double click that one, I'm going to start placing this one in. As it's an IGES file, it brings it in as like a surface looking model. Okay, so we're now going to carry on and add these bits in. So we need to constrain them. So what I'm actually going to do is, because you can see it's kind of translucent, I'm going to go and edit that. You could have done that by double clicking on it, and you can now see we've got the part down here. Okay, and if you right click on the surface there, you see it's got translucent, so I'm going to turn that off, and you can now see it's gone solid. And if you hit return up here, you go back into model, and you can see, because it's one part, obviously it's changed all of them. It just looks a little bit better, I think. So I'm now going to start adding these in. So constrain, And we're just going to use the insert, okay. So I need to use this edge here. And these go onto the underside because these are these countable holes. So you can see how they fit in there. And if yours goes in the wrong way like that, you've got this here opposed and aligned, so you can change that over if you need to. And again, final one. And also, just because I like everything to be fully constrained, I'm going to add those angles in. Ooh. And once you've done that, I'm just going to hit F6 to go back to our home view, and you can see we've now fully constrained our assembly. So all we need to do now is save it up here, and of course it's gone into the correct folder. So I'm going to save that as elbow engine assembly, and you can see the part file is the type of file is a .iam, which is an inventor assembly. Hit save.